long division, which everybody hates but has to be done, synthetic division, which everybody loves, remainder theorem, factor theorem. And then everything will come into play. You'll be like, wait, what? I could have been doing this the entire time? Yep. Do you know how to long divide? Because I don't even think you remember how to long divide. Like if I said, do you know how to divide 52 into 135? Like you know how to make that thing? You do realize that long division of polynomials is the same way, x, and you are going to divide it into your polynomial, which is 6x to the 5th minus x to the 4th. And I'm going to stop right here because do we have an x to the 3rd term? So you need to put what's called a placeholder in, 0x to the 3rd. Then 12x squared, then 15x, and you don't have to put another 0 for the constant. But now, for those who haven't done long division before, this is actually how you do long division for polynomials. You actually only have to look at the front number and this front number. That's it. How can you get a 3x cubed to become a 6x to the 5th? Do you know? 2x squared, right? Isn't that what you multiply by? Okay, so I'm going to put that 2x squared. I'm actually going to not put it over here, here, here. I'm actually going to put it in the squared column. Are you with me on that one? So I'm going to put 2x squared up here. Now, when you take that number and you have to write it for something under here, you actually take this 2x squared and you multiply it to everything in this divisor. So what's 2x squared times 3x cubed? 6x to the 5th. It should be the same. But now do it to this one and this one. What's 2x squared times negative 2x squared? Negative 4x to the 4th. And then what's 2x squared times x? 2x to the 3rd, which is a good thing we put a placeholder here. 2x to the 3rd. Now, do you remember with your old school elementary days, what did you do once you got to this part? Then what did you do with those two? You subtract. Now, here's what I do. When I teach this to Algebra 1 students, I say change, change, change. I just change that whole bottom. I just change those signs because subtraction is adding the opposite. So I just add the opposites right there. Now, if you did it correctly, obviously these two need to cancel. The front needs to cancel. And then just combine these together. If you have a negative x to the 4th and a 4x to the 4th, how many fourths do you have? X to the 4th, 3x to the 4th. And then 0x cubed minus 2x cubed would be negative 2x cubed, right? Okay, now go back to elementary school days. What did you do after that? What would you do with this? Drop down. So plus 12x squared. Do you drop down again? No. Sometimes you do drop down both, but really you just drop down one. And you do that whole process again. What? So you take 3x to the 3rd, and now you look at this. And you say, how does a 3x to the 3rd become a 3x to the 4th? Just x. So you put plus x up here. And then you take x and you multiply it to that. And you take x and you multiply by that. And you take x and you multiply it, and you put it underneath. So 3x to the 4th. Minus 2x cubed plus x squared. Do you all agree? And then you change the signs. Change a sign, change a sign, change a sign. And let's see what we got. Well, that goes away. Well, that goes away. That's okay. Things can go away. 12x squared minus x squared is what? 11x squared. Drop down. Now, what you have left, can a 3x cubed become an 11x squared? No, not unless you're multiplying by a negative exponent, and we're not going to do that. This right here is actually called your remainder, which you all know that, okay? But the way that you write it properly in polynomial terms is you take this remainder and you write plus whatever that remainder is, 11x squared plus 15x, and you put it back over whatever this divisor was. 3x cubed minus 2x squared plus x. And this is your answer, this right here. Now, I know you're like, really? Do we have to know this? I mean, with the level of math that you're going to do, no, you're not going to have anything this complicated to do a long division, but I do want you to do it. There's reasons for it in the future where you have to do long division. It won't be as complicated, but it's really not that hard. It's really the same as elementary. So if you don't know how to do this, you're going to have to do 1 or 2 tonight on homework, but just practice. You just look at the front, multiply, multiply, multiply. The front, multiply, multiply, multiply. I mean, it seems like a pretty easy thing, I hope. But now let's do the easier part, synthetic division, which I know you all know. You couldn't, by the way, do this by synthetic. Synthetic only works with factors. So they're going to do this on homework tonight. They're going to say, okay, I've got 2x to the 4th minus 5x squared plus 5x minus 2, and I want you to divide it by x plus 2. Okay, so this right here is they're telling you this is what you want to divide by. As long as it's written, you can write it in an x minus c fashion, then you can do synthetic division. Now, this is really not written in x minus c fashion, but I could. Do you know how I would write it in an x minus fashion? X minus what would change that to positive 2? Negative 2. So really, this is what you're going to divide by. You're going to change this sign. So you're going to divide by negative 2. And I do it like this. I think Miss Davis just does I do an upside down L, but I make it 2 rows. I think she only does it 1 row. Do you remember what goes on top here? Like what numbers are here? The polynomial. But you've got to make sure that if you're skipping a degree, you put a 0 there. So what I mean is you're going to start off with x to the 4th. This is 2. Do I have an x to the 3rd? So I put a 0. Do I have an x squared? Yes, negative 5. Do I have an x? Yes, 5. And a constant, negative 2. Now, here's how you do synthetic division. It's very easy, but again, it's this algorithm that you got to remember what to do. You always, always, always drop down the first number. Just drop it down. You don't do anything to that front number. Then you multiply, put it here, add. Multiply, put it here, add. Multiply, put it here, add. That's the whole thing. So multiply negative 2 and 2, what do you get?
4.
Negative 4. Put it here, add. Negative 4. Multiply. What's negative 2 and negative 4?
8.
8. Put it here, add. 3. Multiply. Put it here, add. 5 and negative 6 make negative 1. One more time. Negative 2, negative 1. Multiply is 2. Add. What do you get? 0. Now, this last number is called your remainder. Our remainder right now is 0. So what does that mean? What does that mean about this right here? Do you know? If you had a remainder of 0 from like 100 divided by 50, what does that mean about 50? It goes in evenly. It is a what? What? Yay. Thank you, Braxton. This is a factor. I can write of the polynomial. That's very important. We're going to talk about it in a minute. Now, what do these numbers represent? Do you know? Well, this is a new polynomial. That is actually, if I was going back up here to the long division, those bottom numbers are this right here. The remainder would be here, and then that would be your divisor. So this right here, sorry, this 2 is actually now 2x to the 3rd. That's the new polynomial that was divided. This would be minus 4x squared plus, guess what the 3 is? X, and then minus 1. That is actually, if you took this divided by this, you would end up with 2x cubed minus 4x squared plus 3x minus 1 with a remainder of 0. Oh, no way. You always decrease by division of 1. Now, why is this important? Why were you just going on and on about this factor thing, Mrs. Seta? Oh, because of the last two things we have to do today. Factor thing.
Factor out that answer at all.
Yes, if you can keep factoring, but we're not there just yet. But congratulations on thinking ahead. Excellent. So let's talk about this idea of when a polynomial f of x has a factor x minus c if and only if f of c equals 0. What does that mean? That means if you get out a 0, if that is your remainder, then this that you divided by, this factor, this is a factor. If you get out a remainder of 0, then what you divided by was a factor, right? Isn't that what we just found in the other problem? We got out a 0. Oh, it goes in evenly. It's factor. Cool. It's called the factor theorem. The remainder theorem, oh my gosh, it's even cooler. Wait till you see this one. The remainder theorem says if a polynomial f of x is divided by x minus c, the remainder is r equals f of c. This is about to blow your mind. This is about to blow your mind because this is what like Miss Davis was teaching you all last year and you're like, I don't know why she's doing this to us. Why is she torturing us like this? If a polynomial f of x is divided by x minus c, the remainder is the same as if it was f of c. What am I doing here? What is this c? Where's this coming from? From there, right? So what are you doing when you have f of c? What do? We say a little phrase in Miss Davis's room, plug it in, right?
Plug it in.
Right, plug it in. We don't need to plug it in anymore. We could have just divided. And you're like, I don't understand. Have no fear. Let me give you an example and then you'll be like, stop. And I will like, no. Use synthetic substitution to find f of 2 if f of x equals x cubed minus 18x squared plus 60x plus 25. Okay? So back in the day, I'm going to call it the BITD. Back in the day, you would do what with f of 2? What would you do? You plug it in, right? You'd be like 2 cubed minus 18 times 2 squared plus, oh my gosh. I mean, and let's be honest, I'm not having fun right now. 2 cubed is 8 minus 4. I don't even know what 4 times 18 is right now. 72 plus 120 plus, are you with me, right? Wasn't this annoying? Especially if you didn't have a calculator. Okay. Here's what the remainder theorem, just wait for it. Here's what it says. Hey, had you divided, the remainder is your answer. Wait, what? Take 2 and do synthetic division. 1, negative 18, 60, 25, okay? Drop the first one down, that's 1, that's easy. What's 2 times 1? 2, put it right here. Combine, negative 16. Negative 16 times 2 is negative 32. 60 minus 32 is 28. 2 times 28 is 56. 81. Stop it. You mean I don't have, okay. You're going to, according to the directions, use the factor theorem to determine if the binomials are factors, number 1, And if they are, you're going to write it in a factored form. So let me give you again, what does this mean to you? What do you have to do? Well, step number one, you're going to do synthetic division. Almost every problem on the homework tomorrow, you're going to just do synthetic division, synthetic, except for where it says long divide, okay? So step number one, do synthetic division, okay? So I'm going to do synthetic division with -5 or 5, which one? 5, yeah, you always switch that sign, 5. And then I'm going to do the problem again with what? -3. Okay? So up here on this top row, I'm going to put all my coefficients. So 1, -2, -13, -10. 1, -2, -13, -10. And I'm going to get to doing synthetic division that I love. Drop down your 1, multiply, add, multiply, add. I'm very quick at this. You should be too. All right, here's what I got. 1, 3, 2, 0, 1, -5, 2, -16. Question. You should right now be able to look at these two and using the factor theorem, which one works? Which one is an actual factor? The 5 or the -3? Do you all agree? Why? What gives it away? Had a 0. Okay, so that means this one works, this one does not work. X. So you would say x plus 3, not a factor. But x minus 5 is a factor. Okay, so what does that mean? Well, that means you can keep factoring. Again, this is 1. What is the coefficient? What is this the coefficient to? X to what power? Squared. Plus, this is 3x, and this is 2. Right? Okay. Do you know that this can be factored? This is what Ryan was asking before. What does that factor into? X plus 1 and x plus 2. If you take the x minus 5 also, you would get out that right there. You have fully factored that polynomial by knowing one thing that it worked. You are brilliant. You can now factor anything to any degree fully by knowing one factored problem. This is going to help you out so much in the future. All right. Coming to an end here, I'm going to actually do one of your homework problems for you. I think I have enough time to do it. Do you want me to do a homework problem for you? I thought you did.
We'll worry about that tomorrow.
Nah, you want me to do this. But thanks, John. Okay, go ahead. You can make it in the form of x minus c. How can you make this in the form of x minus c? Divide 2 by everything. If you divide it to here, you only need to divide it to here. Okay? So this is really 6x to the 5th plus 5x to the 4th minus 9x to the 3rd minus 6x squared minus 4. And I'm actually dividing it by x minus 3/2. Do you agree to that? Okay. So what goes outside my little L-shaped thing? You've changed that sign, 3/2. What goes here? 6, 5, -9, -6. Oh, they're missing an x. 0, -4. Okay, and now let's see how well you are at fractions because my calculus students are suffering. Bring down a 6. What is 3/2 times 6? Bring down 14. What is 3/2 times 14? What's a half of 14 and then times it by 3? 21. 12. What's a half of 12 but times it by 3? 12 again. 18 again. 18. What's a half of 18 but then times it by 3? And what does that make? 23. Okay, that is my remainder. So now this is my polynomial of degree what? What's the leading degree here? 6x to the fourth. So this would be your part of your answer. 6x to the fourth plus 14x to the third plus 12x squared plus 12x plus 18, and watch, plus 23 over, what did we divide by? X minus 3 halves. Agreed? But in mathematics, we don't like that fraction within a fraction. So do you know how to get rid of it? Just times the top and bottom. Whatever you do to the bottom, you do to the top. So times the top and bottom by 2. So really, my final answer should be all this. Come on, Mrs. Setta, it takes forever to write this. Plus 46 over 2x minus 3. There's 23. And that's it. So tomorrow you'll